Yes, we
sir.
can see. Yeah.
Yes, these are internet times, and we are dependent on the network connectivity and everything. So in the event you lose my connectivity, or if anything happens, the frame gets frozen and everything, just alert me. Otherwise, I will continue to talk, and in the belief that I'm being heard. Okay, so the title of my talk is RPET for food packaging, and is India ready for it? A lot has been said about this thing, and very solid presentations were made giving the background of plastics and the PET recycling technologies. And Professor Edward gave a kind of overview of how the safeties and toxicity limits and everything are calculated. I'm going to present a contrarian view, and this goes directly against the introductory comments made by Dr. Radhakrishnan. So please brace yourself for these things. Before I make the beginning, start my talk, I'm going to have these disclaimers displayed. I'm giving this talk in my personal capacity and not on behalf of any organization. So if any views match, it's only coincidental. These are purely my personal views based on my understanding of the material, the processes, the industry, and what's going on in India. The names of the products and companies, if you see any, are only for illustration. They are not meant as an endorsement or criticism of anything. The contents that I'm presenting are based on the sciences, practices, policies, regulations that I'm witness to in India, and as I've understood them at this point in time, but I'm happy to be corrected on this issue. So materials have been with us or been needed by humanity to fulfill the basic needs such as roti, kapra, and makan, and beyond that for defense, holding medicines, traveling, communications, etc. So materials are needed. And mankind has been using these materials, and so has mankind been doing a lot of activities such as agriculture, manufacture, transportation, services, fuels, etc. So materials and activities are an inherent components of human survival. And we have seen various materials since time immemorial. Even from Mahabharata time, you have Draupadi Vastra, and so silk was known at that time. The Mahabharata is an epic war, a dharma yuddha, which is so metals and everything were known. So a lot of these materials were already known of natural origin. Then came an era of synthetic materials such as glass, ceramics, and paper. And after that, about 2,500, it took almost 2,500 years for a new material to get invented, which we named plastics. Plastics, as we all know, are polymers. Once Professor Staudinger enunciated the concept of what polymers are in 1920, a deluge of new polymers got invented, newer research areas opened up, newer institutions. NCL has a kind of full-fledged polymer, and so have many universities. And to date, 7 Nobel Prizes have been awarded in the field of polymer science. And before I proceed further, I would like to pay my obeisance to Professor Grubbs, whom we lost just 3-4 days ago. He is the one who kind of brought in the concept of olefin metathesis, which is very important for the manufacture of polyolefins. So there have been, the polymers are manifest in various things: plastics, fibers, adhesives, cosmetics, paints, etc. And there are few polymers which have an overlap between synthetic fibers and plastics. So here is a kind of box which shows that there are few polymers such as PET, nylon, acrylic, and polypropylene which exist as plastics as well as synthetic fibers. And this is important when we discuss next. Polyethylene terephthalate, much has been said by the earlier speaker. It's a polymer made primarily with using PTA, that is purified. It's a dicarboxylic acid. Another co-monomer, which is another dicarboxylic acid, and a diol, which is why you get a polyethylene terephthalate. It contains no heavy metals, nor phthalates, nor BPA, contrary to what WhatsApp messages and other things say that. Yet we know that there have been litigations after litigations on PET, which accuse PET of containing BPA, carcinogen. You will find headlines which says that plastics is that kind of some guy, on a WhatsApp video, donning an overcoat, lab overcoat, whose name we never know, but he appears to be a doctor, and then he starts talking about big words such as carcinogen, toxic chemicals, and everything. And the entire brunt of these kind of misinformation resulted in a case against PET and other plastics in the National Green Tribunal, which is a peculiarity in India, which no other country probably has this. The case went on for 7 years. And as we speak, it's been in the Supreme Court in appeal for 1 year. The case has still not been kind of resolved. And this is very important when we discuss the subsequent things. The other parts about polymers having a different degree of polymerization, which then make them useful for various applications, is known to many of you. We need to understand that the plastic chain is not a kind of monolithic body. There are several players in this plastic chain. This also needs to be borne in mind when we discuss whether rPET for the making of packaging for food grade application is India ready or not. Much is said about circular economy. Let us see what exactly it is. And you will find number 7 here because I have been conducting a series of lectures on these things. And this is just my chapter 7 of my talk. So the conventional economy is the linear economy in which you extract, that is take, make, use, and throw. So this has been a kind of traditional economy, and this is a throwaway society. Soon it was realized that this much of waste and reduction in resources is not good for Mother Earth. So therefore, a concept of circular economy has been propounded. What this means is this black box here, or where you extract natural resources, is completely absent, and equally absent completely is the exertion of waste. You could easily understand that this is a very idealistic situation, but where you're now telling that my population, the global population, is increasing. The per capita consumption, the affluence is increasing, the per capita consumption is also increasing, yet I will not have any of these extractions. So those proponents of circular economy need to be told that this is a very high sounding, nice sounding proposal, but in my assessment, a very impractical kind of concept. And we'll see, talk about it in details a little later. So is there nothing that would take away from us from this one? Yes, there is. There is an intermediate model called the chain economy or open loop recycling, in contrast with closed loop recycling. What this says is that, let's be realistic, for the growing demands, if the industry has to survive, if newer industries have to come, more and more plastics will be needed. You cannot expect, the kind of textbookish definition of circular economy to be applied here and then say, I will not extract anything. Some amount of extraction will be needed. Some amount of, we live in real world, so some amount of waste will be ejected. So this is better than this, but this is certainly not a closed loop economy. This is called an open loop recycling or cascading economy. I am a proponent, big fan of this model, and I've considered this model as a kind of too idealistic and just used as a matter of convenience. But more importantly, the concepts of circular economy are still evolving. So it is wrong to use this as a baton to beat bottle to fiber versus, and in order to promote bottle to bottle. The pillars of circular economy is basically to design out the waste. Second pillar is very important, to design for prolonged use. Please remember this when I come next. And regenerating the natural systems. There is another 6 principles of circular economy which says slow, long life of products. Ask yourself a kind of question, is bottle long life or textiles a long life? Small, local, we'll come to all these things, sustainable feedstocks and perpetual. And the word downcycling is also used very conveniently without understanding what it means. We'll come to ask ourselves, what is recycling? So basically, the ISO gives a kind of framework on how materials after the segregation at source can be recycled to recover material or to recover energy. We will not go into this details at this point in time, Just goes to show that there are several, the world over, several recycling standards or regulations for allowing recycled materials for packaging of plastic or plastics for packaging purposes are existing in the USA, Japan, and also in India. These are the standards. However, Indian regulations such as the FSSAI, Food Standard Safety and Standards Authority of India, and the Indian Pharmacopoeia Commission prohibit the use of recycled plastics, including recycled PET, for the packaging of food and pharmaceuticals. And it's been there for the past 20-25 years for good reason. So suddenly come 2021, we want to say that all the wisdom that went into the making of these regulations are no longer valid. So all the people who kind of framed these regulations, and the laws and everything were all wrong. And suddenly come 2021, they are to be disproved and overturned. This is what is happening. Circular economy can be ensured as follows. So there is a big chain of the plastics supply chain here. I won't go into the details here, but starting from the crude oil extraction, refining, resin manufacture, plastics manufacture, and finally through the retailers, it comes in the hands of consumers. Once the consumers use it, they either have an option of littering, which is what happens globally. No need to beat Indians with it. And or to segregate it responsibly, blue for plastics or recyclables, green for wet waste. Once that is done, the multi-material or multi-layer plastics, which are difficult to recycle, can be used for road making or for energy recovery. The ones that are made of only polymers, a single polymer, a clean one, can be amenable or best done by mechanical recycling, in which case a bottle, for example, can be converted back into bottles or other materials of the same nature, of the same chemistry. The further you go down, there is a chemical recycling which can handle dirtier material, dirtier packaging, in which case you can go back to the level at polymer, and even dirtier material can be subjected to pyrolysis or gasification, in which case you go to the monomeric level or even earlier than that, such as making the oils. The circular economy of plastics is a given. How does this happen? The same thing is kind of explained here. So you have chemical processes which convert into naphtha or BTX, benzene to xylenes, which are then used to convert monomers, which are then converted into polymers. Polymers are then made into plastics. So this is the forward chain, in which finally it reaches the consumers. Then begins the reverse chain. So the waste material is collected. This is a very important step, and then subjected to mechanical recycling. So this is the closest loop, least energy intensive. Okay. But if the material is not very clean, mechanical recycling cannot handle it. So you go for dissolution, in which case you make the polymers. So you then ensure the circularity here, but do note that the circularity, the ring has now expanded, which means more steps have come here, more energy, and longer you go away from the end product. And the same thing can be taken back. You can go for depolymerization, or you can go for pyrolysis, or you can go for gasification. Whereas all these processes will ensure a circularity. You will realize that as you go from here to here backwards, so as you go from mechanical recycling into, these are all chemical recycling. The remaining 4 are chemical recycling. As you go into chemical recycling, you're flattening the circular economy more and more. So although you are claiming to kind of loop it back into this material, you're investing more energy and costs into these things. Does the circular economy definition take into account these things? It is a kind of misconception and misleading to say bottle banaya, so therefore circular economy. It is one of the most mischievous kind of arguments that we cannot encounter. Let's see what is chemical recycling. So there is pyrolysis, which is primarily done in the absence of oxygen, and you get plastic oils. There are several other subcategories, whether it is non-catalytic or catalytic or plasma pyrolysis. And there can be some other techniques as well. We'll not go into the details at this point in time. If there is an energy or interest, we will look at it in details. Gasification is the further step after pyrolysis, in which there is not a total absence of oxygen, but a little limited amount of oxygen and or steam or air is in contact with the plastics, and in which you produce what is called syngas, which is then used to make further monomers. Next is the case of solvolysis, in which it's a chemical recycling in which feedstock specific solvents are used, such as hydrolysis or glycolysis, in which depolymerization happens. So solvolysis has two subcategories. One is depolymerization, or the other is purification. In the depolymerization, you have hydrolysis or glycolysis, and as the first speaker very correctly, very nicely explained, these are the techniques in which you break down the polymer into whatever stage you want to take it back to. You can unzip the polymer to the level that you want to. Purification, on the other hand, is just as it says, you dissolve the polymer and using a non-solvent, you precipitate the polymer. Just the thought of it and picture of it, you can visualize the amount of solvent and the recovery, solvent recovery, and the heat and the risks involved in these things. Does circular economy capture these aspects? Ask yourself these questions at every point in time. The one more technique in chemical recycling is hydrothermal liquefaction, in which water is used at elevated pressures and temperatures to produce oils and chemicals. There is a biological recycling, such as enzymatic recycling, hydrolysis, in which enzymes found in waste bacteria, which live on a diet of plastics, produce enzymes that break PET, for example. Any enzyme that breaks a specific particular substrate, the name is followed with ase. So if there is an enzyme which breaks PET, it will be called petase. So it will then, the bacteria have been engineered to break PET so that it goes back into its building blocks monomers such as PTA or MEG. These are all very nice to hear and produce papers and kind of publish papers and probably speak at conferences. We will look at that, what is the real practical level at that. So here is a snapshot of all the recycling technologies that I just mentioned. You have the conventional mechanical recycling, in which you have bottle to fiber, in which the bottles are broken into flakes and the flakes are directly processed to make fibers, textile fibers. In the case of PET, it is polyester fiber. Or it's the B2B recycling in the mechanical, in which the flakes are converted to pellets, which are then solid state polymerized to make bottles. And then there is thermolysis, chemolysis, or biological. We have seen all of this in the past. What is important here is various, for all these technologies, recycling technologies, what is the range of plastics produced? Here is a snapshot which gives the entire picture of recycling technologies at one place. What is the range of plastics processed? Is the range narrow or wide? What are the mixed, can it handle mixed waste? What are the process temperatures? All of this is listed in it. It's a crowded slide, but just tells you the kind of thought that needs to be put into the mind, into your assessment before you make any claims that a certain process is available or not available. Process temperatures, as you will see in the case of mechanical recycling, are very low compared to other technologies. How far are they? Much as people might claim that the EFSA has approved this, US FDA has done this, XYZ have done this. All the claims are good for showing PowerPoint slides. Are they anywhere near reality? Let us look at the total operational capacity. Of all these technologies, chemolysis or plasma hydrolysis or HTL technology or gasification, they are very, very in the nascent stage. In fact, some of the technologies are nowhere in operational capacities, like the melt filtration mechanical recycling is. What is this mechanical recycling? It is the conventional recycling of PET. How is PET done? What is PET? You have polyester, polyethylene terephthalate. This is not the only polyester. Any molecule which has multiple ester units is a polyester. It need not always be polyethylene terephthalate, polyethylene naphthalate, polybutylene terephthalate. All of these are polyesters. But we are speaking about presently polyethylene terephthalate. This is made by melt polymerization using PTA, IPA, MEG. We have seen that. Textile processes. Those of you are familiar, these are filament yarn processes. The other are staple fiber processes. Those of you are not familiar, do not be daunted by these things. Just tell yourself that the textile routes has so much of variety of plastic or the textile materials that can be made. Staple fiber, fiber film, non-wovens, partially oriented yarn, fully drawn yarn, industrial yarn. Compared to this, let us see what happens the same textile grade material, that stream, when it is subjected to a solid state polymerization. Please remind yourself that earlier it was a melt polymerization. You then extrude that and make the chips and subject them to solid state polymerization to make what is called PET. Same molecule, different word. Why? I don't know. It's just a kind of industry norm. The word for this molecule is PET. The same molecule in its previous avatar is called PES. And this PET can then be used for packaging applications such as bottle. Same molecule, same chemistry, a healthy IV or molecular weight used for producing so many things the world over. Same molecule, another healthy, upgradation or upgradation meaning increasing of molecular weight, now ready for bottles. What is the molecular economy? The same virgin PET molecule, 50 million metric tons per year globally is used for making textile grade polyester fibers or yarns. Half of it is made for use for making PET bottles. The ratio is 2:1. Just keep this in mind. I'm going to lead you to an interesting observation. So forget the numbers, actual numbers. Textile grade polyethylene terephthalate is twice the material that is needed for bottle grade. So 2 molecules and 1 molecule. Just look at that. So if there are 3 molecules, 2 go for making textile materials, 1 goes for the making bottle material. When we discuss further, let us remind ourselves that not all dismantling mechanisms of polymers are to be called degradation. Degradation means different, decomposition means different, molecular size switching means different, shredding means different, disintegration means different. A lot of these things are used interchangeably depending on either convenience or mischief. In the case of PET, when the bottle is broken from the bottle stage to textile grade flakes, it is merely a matter of molecular size switching, moving from higher to a standard IV, higher IV to a standard IV. Okay, we'll see why this is important for us. A lot has been said about 90% of PET, and this has been arrived at this figure by a branch of NCL called Venture Center, who were commissioned to do a practical on-field studies to see how much exactly is PET recycled. And through field studies and the application of robust statistical models, they have, and studying the kind of annual reports and everything. So actually a first attempt probably in the world to do an objective study of how much polyester gets recycled in India. They concluded that 70% of the PET bottles get converted to textile applications, such as fibers, which we saw. Another straps, films, and other make 10%, and another 10% remains indoors, either at home or whatever it is for different purposes. So only 10% gets into street litter. So that is how the 90% figure has come out based on NCL's study. And this report is available at this website. There is another institute, ILSI, International Life Sciences Institute. They have also, through their studies, arrived at a similar figure, 80%. So these figures fairly match. So it is reasonable to assume that this is the correct figure. And therefore, there are about, this being a lucrative business, there are about 41 companies who are in the business of making textile fibers, polyester fibers from used bottles. How does it happen? This is an important slide for those of you who are interested in knowing whether India is ready for it or not. So we have seen that the raw materials are subjected to melt polymerization to make chips, PET chips, which are at this stage they are at the textile grade. Their IV intrinsic viscosity is about 0.64. Part of it then is then subjected to textile applications, a kind of tree that I just showed you. But a part of it, half of it is chipped here and taken to solid state polymerization, where the IV is not 0.64 but higher, that is 0.72 to 0.84 or whatever it is, depending on what the bottle grade resin is for. The resin grade is for what kind of bottle? Is it for water bottle or is it for CSD bottle, or depending on that, you can have various IVs. Now, this bottle grade IV is then subjected to injection molding, during which, because of the heat and shear stresses, there is a drop in IV already. And this IV drop is matching back again at the textile grade IV. So already there is a drop in the IV here, which is then of course converted to preform blow molding bottle, etc. And then comes the usage phase. At this stage, the used bottles are then collected by the rack pickers, goes to Kabadiwala, and there is a very nice established chain, which is then goes to a recycler who operates the wash line, as it is called, where it is PET is segregated from different other plastics and other materials through magnetic separation and float and sink methods and everything. And what comes out is the clean flakes, which has the dropped IV. So which is at this stage, the IV is exactly right fitting for textile grade. And this is why even technically, bottle to fiber makes tremendous sense. Technically, can these flakes be upgraded to bottle? Of course they can. But just tell yourself, remind yourself, the flakes will need to be kind of molten into chips, subjected them to solid state polymerization at 210 degrees for 18 hours. Look at the amount of time and the heat energy. So those of you who are environmentalists need to ask yourselves a question. Why are you doing these things? What exactly is the objective? Is it the clearing of the street litter? Is it the reduction of fossil-based resources? Is it the reduction in greenhouse gas emissions? What exactly are you trying to do? Based on that, please form an opinion. This is the same thing, which is in a much detailed thing, probably not right for this time, this audience, considering the time. But if you, having done the textile grade route, here is the kind of variety of materials that can come and that have been actually in practice. So you can make blankets out of this thing, your automotive upholstery can be made, and Indorama, one of the major companies, uses the PET bottles. What can be more topical than converting, the coverall suits, PPE suits, fighting COVID? And the way it is done is the bottle scrap is taken and converted into staple fibers, which is then converted into yarn. These are conventional textile mill operations. And then the garmenting processes such as PET. And you can then form a variety. This is just an example of what all you can do with it. And not just textile materials, you can also make tapes and other materials out of this thing, and pillows, the fiber fill materials that you see these days, or carpets, or basically non-apparel textiles. See the kind of rich spread of materials that you can make in the bottle to fiber process. Bottle to bottle, on the other hand, is bottle to bottle. That's it. No other bottle to bottle. Whereas here you can make bottle to t-shirts, bottle to carpets, bottle to fiber fill, bottle to tapes, bottle to curtains, bottle to apparel. Now, this is important when we discuss further, and this is just another kind of, list of the items that can be done with the recycled bottle, and not just textile or apparel purposes. Even the branded goods such as Samsonite luggage and everything is made out of recycled PET fiber, and even your detergent bottles. So as long as the bottle to bottle conversion also, as long as it is not for food grade application, it's perfectly all right. And for sports turf. And for those of you who have a chemistry background, the same PET bottles can then be converted into chemicals of a variety of kinds. But what is shown here are textile chemicals such as dyeing auxiliaries, hydrophilizing agents, backstaining, anti-backstaining products, etc. So fantastic recyclable material. Yet it is subjected to the kind of comments that we heard in the opening comments that, oh, it is not recyclable or it's downcycling. We need to ask ourselves, what is this downcycling, upcycling game? It's a word game. You want to promote this, you use the word downcycling. You want to beat that, you use the word downcycling. What happens in PET? There is no thermal or molecular degradation. As we just saw, it is moving up from one desired IV to another healthy IV to another healthy IV. There is no molecular degradation when you convert the bottles into fibers. Why then should you call it downcycling? The increase in financial value. A shirt made of recycled polyester will cost you in a branded chain would cost you 3,000 rupees, let's say for 300-gram shirt. A 1 liter bottle of a water bottle or any kind of beverage bottle would weigh 25 grams. So to make 300 grams, you will need to have 12 bottles. Now you convert the bottle back into the beverage bottle and fill in 1 liter, 12 bottles. I don't drink a lot, but those of you who drink, some of these beverages and all, ask yourselves, what would a 1 liter bottle cost? It would cost, I don't know, let's say 100 rupees. I don't know, 100 rupees. 12 bottles is 1200 rupees. So bottle to bottle will fetch you 1200 rupees, whereas bottle to fiber will fetch you 3000 rupees. Which one adds to the financial value chain? So neither there is any technical degradation nor a financial, in fact, in financial, there is an upgradation. Why then call it downcycling? If at all, it is the right cycling. So therefore, B2B is kind of labeled mischievously or misinformed. There is another argument of safety, which actually goes in favor of bottle to fiber. I mentioned about the cases going on for 7, 8, 9 years in the courts in India. It's typical in India, where leaching is kind of alleged. Now, if you were to convert bottles into fiber, leaching related concerns don't arise. You just wear a shirt and then you go away. There is no leaching related concern. There is no relevance of the worry about UVCBs, which is UVCBs are chemicals, those chemicals who have unknown or variable composition, complex reaction products, and or biological materials. Multiple recycling of bottle to bottle is known. There are reports that it generates UVCBs, so we don't even know what to test for. When you don't know what to test for, merely saying that now this recycled bottle grade material matches the specifications of virgin, therefore allow it, is misleading. Scientific community should not do that. Because this is a new animal, we do not know. A recycled stream could have probably a material which has seen 1 recycling cycle, 3 recycling, 18 recycling. You don't know. You have lost track of it. And therefore, the presence of UVCBs is very, very high. So therefore, B2F is unquestionably safe for humans. And therefore, B2F has a distinct advantage over B2B. What are the logistics issues? As we saw, there are 41 plants spread all across India for B2F. The supply chains are completely established in India. This is not the case in the Western world and all, which are kind of the Europe and other places, which they are kind of pushing these materials. Fiber, polyester, bottle to fiber is a very fantastically established chain in India. It's the strength of India. The textile chains are already in their advanced version. India is a very advanced country with very advanced textile technology. So you want to break that only because you want to promote bottle to bottle. But more importantly, with 90% of PET bottles already picked up for B2F route, where is the stock available for B2B to fulfill the need of, the kind of huge need of bottles? And then RPSF, that is recycled staple fiber, is competitively priced, whereas our bottles are expensive. Therefore, RPSF are a customer's delight, and we will see the kind of pricing here. These are the pricing in 2020 last year, and I'll show also this year. And these are, of course, the European and US pricing, where the cost of recycled PET in Europe is twice that of virgin PET. In US, it is 1.25 times. India is a price sensitive market. And here already we are talking about, very expensive material, because I just explained to you, because of the energy costs and everything goes. And this is for 2021. So recycled PET food grade pellets are 1.8 euro per kilo. And the virgin are only 1.45. Again, huge difference, and the difference is just increasing year after year. Now we come to this dreaded question of circular economy. Circular economy nahi baithta. So that is the case. No textile fiber would fit the theoretical definition of circular economy. Cotton does not fit circular. But same thing can be said. अरे वो 20 साल पहनने के बाद cotton fiber का क्या होता है? You throw it away. Yes, all fibers. But silk sarees, silk materials, in India at least, are passed from generations to generations, elder brother to younger brother. So it remains in the system for decades. And what happens to bottles? You use it once and then you throw it away. So which has a higher life? And if you recall the 3 pillars of circular economy, here the molecule stays in the system for long. B2F is an example of cascading economy, which I explained. It's an open loop recycling. B2F keeps the molecule in the system for decades, as I just explained. And many critical other materials, like for example, food. Can you apply the circular economy model to food? Can you bring it back food? Fuel, if you burn the fuel, can you bring it back into the system? So it's not a circular economy. Can you then say, aha, because it's not circular economy, it's not good? Therefore, it is circular economy is not a holy grail. It's a good concept, but it's not the concept that if some material doesn't follow, you can beat to death that other material. More importantly, concepts of circular economy are still evolving. It's not complete. And at the end, I will explain to you during debates how many things are not known about circular economy. Usefulness. Textiles are basic, bottle to fiber, textiles, which that converted textiles are basic human needs. Bottles are not basic human needs. So you would go for bottles or for textiles. Textiles are used over generations. Bottles are needed only for minutes. These fulfill your basic needs of survival. This is only for pleasure. So B2F is an example of useful economy, even if it is not for circular economy. And the variety that you can create out of fibers is the huge kind of variety which we have explained earlier. The technology for converting B2F is a mature technology platform in India. You have ring spinning, you have air jet spinning, so many spinning those of you who are familiar in textiles would know the kind of numerous spinning technologies, non-movement technologies that exist. And textiles have a wide menu of formats, which I just showed: staple fiber, fiber fill, shortcut fiber, partially oriented art, fully drawn yarn. In the case of bottles, it's bottles versus bottles versus bottles. It's only bottles. Still, bottle to bottle is just beginning its journey. It is not to condemn this versus that, but it is to make an informed judgment that is India ready for it. Because bottle to fiber is an example of a reliable economy, even if it's not a circular economy. And let's see how the world, the globe, Europe, the same European standard which is touted, what does it do? Here is the 2019 regulation that Europe has brought about, which is called SUPD, Single-Use Plastic Directive, 2019/904. As I speak, please look at it. European Article 6 says that only until 2025, only 25% of recycled bottles shall be used for PET bottles for beverages. Which means,
Dr. Habbu, you have 5 minutes to go.
Yeah, these are the last 2 slides anyway. So even Europe is an advanced country which is pushing for their own regulation. This is not mine. This is their streams from their regulation. They are saying that by 2025, you can use only 25% of recycled plastic. And by 2030, you can use 30% recycled. So when Europe itself is going cautiously on these things, why should we rush to ask for 100% recycled material or significant recycled content? So what is achieved by a lot of companies saying that we will use by 100% commitment that recyclable material, and then there is this group which says we'll use 100% recycled material by so and so date. What exactly is achieved by that? Merely because the packaging contains X% recycling, will consumer change the habit of their littering? Aha, here is a bottle, it contains recycled, so I will not throw it away. The littering habits will continue. Because now companies have started using recycled bottles, will the civic administrations improve their street cleaning? So what will be the impact on the visible litter? So these are the societal effects. And the cumulative effect on the recycling content, on the mechanical properties, on leaching, on the formation of microplastics, none of this has been studied. So therefore, and we have all these regulations, governmental push coming in. I'm not going to go into the details, but instead of going for B2B, we should actually ban B2B in India for food packaging. And if at all we want to increase the street litter and everything, increase something in the resin manufacture, additives that are induce biodegradability, that are additives that induce compostability, should be prohibited. What should also be prohibited are the PVC labels on PET bottles, because the density of PVC and PET are the same, so it does not get separated in the float and sink wash line and technique in the wash line, and therefore then that PVC, then residual PVC, causes problems, which is what is also a significant danger in the bottle to bottle recycling. So with this, this is the last slide I will say, as we proceed through the times, 2024, India is going to overtake China in population. This is not a race we would like to win. But with this, the amount of plastics and PET that will be consumed is going to be that much more. So therefore, we need to be very cautious and smart about our decisions. Unlike pandemic, we are a lot of smart people, but our smartness should not be asymptomatic. We should be very sensible in what we claim for. Thank you.